80% of the state of Florida is in extreme drought. 99% of the state is in some level of drought. According to the Florida State Climate Office, these are the worst conditions the state has seen in a quarter century. But the reason this drought is different is not Florida. It is a study that was published 48 hours ago. Here's what it says, and why every number just changed. Florida is a state that averages roughly 55 inches of rain a year. It is not supposed to burn. And yet the Florida Division of Forestry has already logged more than 1,500 wildfires in the first 3 months of 2026. That is an average of well over 15 fires a day across a state whose forestry budget is already stretched to the breaking point. The agricultural damage is running the same way. Losses across Florida have already passed $3 billion. A January freeze destroyed citrus, strawberries, and vegetable crops that were already stressed by months without meaningful rain, and the compounding damage of freeze plus drought is what pushed those losses past the $3 billion line. Now the water supply itself is tightening. The Floridan aquifer is the primary drinking water source for roughly 10 million Floridians. As of this week, it is at its lowest level since 2011. 11 counties have enacted mandatory or voluntary water restrictions. Lake Okeechobee is at historically low April levels, and the Army Corps of Engineers is actively managing releases to preserve supply. What you are looking at, if you live in Florida right now, is a state that is watching its reserves draw down in real time, with the peak of fire season still ahead and no significant rain in the forecast. And Florida is not the edge of the story. Florida is the middle. Alabama is 100% in drought. Not most of Alabama, every square mile of it. The U.S. Department of Agriculture has designated 30 Alabama counties as primary disaster areas due to drought-related agricultural losses. That is a federal disaster declaration covering the majority of the state, and it happened fast. As recently as February, Alabama had patchy moderate drought and no statewide emergency. Roughly 8 weeks later, the state is fully covered. That speed of expansion is the part meteorologists are flagging. South Carolina is at 93% in drought. Georgia is at 96%, with Atlanta area reservoirs already in decline. Middle Tennessee is at 80%, and the National Weather Service office in Nashville has publicly flagged rainfall deficits exceeding 5 inches below normal for the period. This is not a southern Florida story. This is a regional footprint that extends from the Gulf Coast up through the Appalachian foothills, and every state inside it has moved into red alert territory within the last 2 months. At the national scale, 60.05% of the contiguous United States is now in moderate drought or worse. That number has climbed steadily every week since late February. 51% of U.S. states have areas in moderate drought or higher. It is worth being precise here. The 2012 national drought peak hit just over 65%, so this is not a record-setting national event. What makes the current moment exceptional is the eastern footprint, Florida at its worst in 25 years, Alabama at full coverage, Georgia and South Carolina in the mid-90s. The South has not seen a regional drought this aggressive, this fast, in decades, which leads to the obvious question: how is this even possible right now? The driver is a single atmospheric feature, a Bermuda High. It is a large, persistent area of high pressure parked over the western Atlantic, and this spring it has been anomalously strong, anomalously stubborn, and positioned in a way that diverts moisture away from the southeast before it can produce rainfall. If you have been watching the record April heat in the mid-Atlantic, the low 90s temperatures, the daily records falling up and down the eastern seaboard, that is the same Bermuda High. The heat and the drought are not two separate stories. They are two faces of the same atmospheric pattern. Here is what makes it strange. We are currently in an ENSO transition. La Niña has been weakening for months. The Oceanic Niño Index, which tracks sea surface temperatures in the equatorial Pacific, has climbed from minus 0.55 up to minus 0.16 over the last 6 months. The Pacific is warming, and a warming Pacific typically shifts atmospheric patterns in ways that deliver more moisture to the southeastern United States. That is the textbook expectation during a La Niña exit. But the drought is getting worse anyway. The southeast drought footprint has expanded every week since late February. Parts of the region have gone more than 10 consecutive days without any measurable precipitation. The broadcast meteorologist Jim Cantore publicly flagged the dry pattern as exceptional. So we have a blocking pattern strong enough to override the ENSO signal, a Bermuda High strong enough to simultaneously bake the mid-Atlantic and starve the southeast, and a drought footprint that is expanding in a phase of the climate cycle that should be producing the opposite outcome. That is unusual on its own. It matters because it tells us the pattern driving this drought is not a normal La Niña hangover. It is something more locked in. This, by itself, is a serious story. This would justify the coverage, but the reason this drought is different, the reason you're watching this video, is because of a study that was published 48 hours ago. On April 14th, 2026, researchers led by Portman and colleagues published in the journal Science Advances the most tightly constrained observational estimate yet of how fast the Atlantic Meridional Overturning Circulation, the AMOC, is weakening. The headline finding, approximately 50% weakening of the AMOC by the end of this century. The full range in the study is 42 to 58%. The central estimate is 50. What makes this study different from every previous AMOC projection is the method. Most long-range climate projections rely on ensembles of climate models, what are called CMIP6 models, that simulate the behavior of the global ocean and atmosphere. Those projections are valuable, but they have a known problem. They carry a wide uncertainty window, and they have historically underrepresented AMOC weakening. Portman's team used a technique called ridge regression, applied to observed sea surface temperature data. In plain language, instead of asking a model what the AMOC will do, they looked at what the ocean has already been doing and constrained the projection with real measurements. The result is twofold. First, the uncertainty window narrows dramatically. Previous AMOC projections spanned a range so wide that policymakers could reasonably dismiss the worst case as an outlier. Portman narrows that range. Second, and more importantly, the study finds that most CMIP6 models have been underestimating the observed weakening signal. The real ocean is tracking toward the alarming end of the model spread. That is the finding that matters. Previous projections had a best case and a worst case, and the worst case always felt distant. Portman's observational constraint says the worst case is not the outlier. It is the trajectory. And this connects directly back to what is happening in Florida this week. The drought you're watching expand across the southeast is what broken moisture transport looks like at a regional scale, driven by a weather pattern. The Portman study describes the mechanism that could break moisture transport at a hemispheric scale, driven by a climate trend. One is a season, the other is a century. But the physics of the problem, the failure of the atmosphere to deliver rain to the places that expect it, is the same problem at two different scales. That is why these two stories matter together, not as cause and effect, but as two snapshots of the same failure mode. The Atlantic Meridional Overturning Circulation is an ocean conveyor belt. It transports warm, salty water from the tropics northward through the Atlantic and pulls cold, dense water south along the deep ocean floor. The numbers on this system are enormous. It moves approximately 20 million cubic meters of water every second. That is roughly 100 times the flow of the Amazon River. It delivers approximately 1 petawatt of thermal energy to the northern hemisphere, 1 quadrillion watts of heat. And it is the single biggest reason Europe is 5 to 10 degrees Celsius warmer than equivalent latitudes on the other side of the planet. It also controls where rain falls. The AMOC influences the position of the intertropical convergence zone, which is the band near the equator where most tropical rainfall is generated. When the AMOC weakens, the ITCZ shifts south, and the pattern of tropical rainfall across the Americas, Africa, and parts of Asia shifts with it. This is the mechanism that ties the ocean current to what happens in Florida. A weakened AMOC does not just cool Europe, it changes the address where rain gets delivered. The engine of the system is deep water formation near Greenland and Iceland. Cold, salty water gets dense enough to sink, and that sinking pulls the whole circulation forward. What is weakening that engine right now is fresh water, specifically Greenland ice melt. As fresh water pours off the Greenland ice sheet into the North Atlantic, it sits on top. Fresh water is lighter than salt water, and it inhibits the cold, salty water below from sinking. The more Greenland melts, the more the engine slows. And the Greenland melt seasons of 2024 and 2025 both broke consecutive records. If the 2026 season makes it 3 in a row, the Portman 50% by 2100 projection could arrive decades earlier than the paper states. A prior study out of University College London and Woods Hole Oceanographic Institution, published in 2021, found that the AMOC is already at its weakest point in 1,600 years. That study documented a 15% decline since 1950. So when Portman says 50% by 2100, that is a projected slowdown on top of an ocean current system that has already lost significant strength compared to any measurement window we have on it. So when you hear the phrase 50% AMOC weakening, here is what it actually means. It means the ocean current system that sets European temperatures, governs tropical rainfall, and moderates northern hemisphere climate, is projected to operate at half strength within the century. The system telling rain where to fall will be fundamentally disrupted. And if that happens, droughts like the one Florida is facing this week do not stay anomalies. They become features. The Portman study projects 50% weakening by 2100. That is the long horizon. But Portman is not the only data point. Two other pieces of AMOC research stack directly on top of this. The first is Ditlevson and Ditlevson, a 2023 paper published in Nature Communications. That paper did a statistical analysis of AMOC behavior and projected not just weakening, but outright collapse, full shutdown, somewhere between 2025 and 2095, with a central estimate of 2057. The second is Stefan Rahmstorf at the Potsdam Institute for Climate Impact Research, who has studied the AMOC for 35 years. Rahmstorf has publicly stated that there is greater than a 50% chance of AMOC shutdown, potentially in the middle of this century. He has called AMOC collapse one of the most dramatic climate changes in 100,000 years. And for context, the most recent IPCC assessment, AR6, characterized AMOC collapse as low likelihood, high impact. The observational data coming out now, Portman in particular, is running ahead of that framing. The science is moving faster than the consensus summaries. That is worth paying attention to. The timeframes here are the part that should register. Ditlevson says 2057. Rahmstorf says mid-century. Portman says 50% weakening by 2100 is the best constrained observational estimate. These are not geological timescales. 2057 is 31 years from now. The families looking at their water tables drop in Florida. This week are the same families who will live to see those mid-century estimates play out. This is not a problem for the grandchildren of the people watching this video. This is a problem for the people watching this video. We actually have a historical analog for what a disrupted AMOC does, and it is called the Younger Dryas. Roughly 12,900 years ago, a massive influx of glacial meltwater shut down or severely weakened the AMOC. The consequences showed up fast and they showed up big. North America cooled by approximately 3 degrees Celsius within decades. Europe cooled by 2 to 6 degrees, with parts of the continent reverting to near glacial conditions. Greenland ice cores record temperature drops of up to 10 degrees Celsius. And that cold period lasted approximately 1,200 years before the AMOC restarted. Tropical rainfall patterns shifted dramatically during the Younger Dryas as the ITCZ migrated south. Regions that had been wet dried out. Regions that had been dry got wetter. The geography of rainfall was rewritten for more than a millennium. Projected consequences of a modern AMOC weakening track similar territory. An additional 50 to 100 centimeters of sea level rise along the U.S. East Coast beyond thermal expansion. Paradoxical cooling in Europe of 3 to 8 degrees Celsius, even in a globally warming world, and a projected drop in European arable land from 32% down to 7% under full collapse scenarios. Now, the Younger Dryas is not a perfect analog for modern AMOC weakening. The mechanism is different. 12,900 years ago, the trigger was a catastrophic drainage of glacial lake water, probably from the retreating Laurentide ice sheet. Today, the mechanism is a gradual, accelerating loss of fresh water from the Greenland ice sheet. The speed is different, the scale is different, and the uncertainty is different. But the physics of what a weakened AMOC does to climate are the same. That is why paleoclimatologists reference it so often. And before we leave this section, one quick note on the claim going viral online that cloud seeding or weather modification programs are deliberately creating the southeast drought. The data does not support it. Cloud seeding operates at scales orders of magnitude smaller than a multi-state drought, and it cannot create drought in the first place. It requires existing moisture to work. What is drying out the southeast is a well-understood atmospheric pattern, a persistent Bermuda High blocking moisture transport. That is the mechanism, not modification, blocking. The U.S. Drought Monitor releases its next update on Thursday of next week. Watch for whether the southeast footprint is still expanding or whether it has finally plateaued. An expanding footprint 7 weeks into the event would push this from severe to historic for the region. This week also has a severe weather outbreak on the way. The Storm Prediction Center has an enhanced risk for Friday across Oklahoma, Kansas, Missouri, Iowa, Illinois, Minnesota, and Wisconsin. That will bring storms to the middle of the country, but it will do very little to relieve the southeast drought. The same Bermuda High starving the south is helping load moisture and instability into the severe weather target zone. The contrast this week will be sharp. Tornadoes in the plains, no rain in Florida. Florida itself enters its most dangerous fire stretch now. Peak Florida fire season runs through May. The state will be entering it with the driest fuel load in 25 years. If you live in Florida, watch for red flag warnings and voluntary evacuation orders. The Division of Forestry is already stretched, and any additional wind event could turn a contained burn into a regional incident quickly. Medium term, watch the ENSO transition. If El Niño emerges this summer, it typically delivers more moisture to the southeast. But if the drought holds even as La Niña fades, the blocking pattern is the dominant signal, and relief will not come from the Pacific alone. Long term, watch the 2026 Greenland melt season. 2 consecutive record years are already on the books. If 2026 makes 3, AMOC timelines compress, and the Portman projections start looking conservative. Here's the takeaway. The drought in Florida, Alabama, Georgia, South Carolina, and Tennessee is real. It is severe, and it will eventually break. Weather patterns shift. Rain returns. But the Portman study that dropped 2 days ago describes a future in which the system responsible for deciding when and where that rain returns is operating at half strength. This drought is a regional event driven by weather. The next one, or the one after that, may not be. That is the question the science is now asking. We will be tracking it as it develops. Thanks for watching the Space Desk, and see you in the next one. Stay safe out there.